Hi, my name's Callan. This is my first video of what I hope will be many, talking about creating back-end web applications and front-end web applications using Node. My first application that I'm going to be talking about is Moneylog, which is a simple list application which allows you to create logbooks and then fill those logbooks with transactions. Now, I created this to kind of help me with my own keeping track of my transactions and finances, and as a way of kind of following sort of money bucket style thing, and kind of just to, I guess, increase the transparency on where my money is going and kind of give me a playground to plan, shopping lists or other things like that. So I'll get stuck into the backend tests because I think this is one of the coolest parts of the whole backend application. I absolutely love tests because I feel like these days you can learn a lot about a piece of software by looking at the tests. Oftentimes, especially if there's not very good documentation for something, you can generally get stuck straight into the tests and actually see exactly how the interfaces work and exactly what should be going into them and what the developer expects the outcome to be. It also allows you to see potentially, kind of, if you read them sort of like a book, then you'll be able to kind of build up an image and a story in your head about what this application can do, and how it's expected to function. So I've created essentially 5 main kind of divisions in the testing. One essentially for each group of routes. So a group of routes being, say, for example, / logbooks, and then anything under that. So in the logbook tests, I have some tests for creating a logbook, whether you're logged in or not, attempting to access another user's logbooks for security purposes, fetching a list of logbooks, again, as a user that's allowed to and a user that's not. Things such as making sure that the currency property is updated, deleting logbooks. I've really used the concept of resource owners and resource owner password credentials, which I remember from a number of the HTTP or OAuth specs, I should say. I absolutely love OAuth 2, and one of the coolest things I think that there is to it is actually the resource owner password credentials, because it's the mechanism that allows you to just log in with a username and password, rather than going through a full OAuth flow. Now, while I say OAuth and I throw OAuth around, to think that this application is OAuth would be wrong, because I've just brought in some of my favorite concepts from OAuth and put them in here. So we'll start with the helpers. So the main helper that I've created here is an API helper. So I've added this Jasmine start test API and Jasmine create test client. The start test API literally creates an instance of the API and assigns it to a port for testing. And then I have create test client, which creates an instance of this API test client, which has a lot of sugar functions on it for, say, things like creating a unique login, generating a password, logging in, so attempting auth, and then returning the token and the user ID. A user initialize function, which is again another sugar function, just when we just need to bring a new user into existence. Basically what it does is it signs up a new user and then it logs them in, and then returns the information about that user and their session. Then I also have a sign-up function, a sign-up method. Again, it just kind of wraps around the existing sign-up functionality that I've put into the application and just does a post request with a new login and password. I have a get method, which you can pass an authorization and then the path that you would like to access, and then it does a GET request to that path using the authorization provided, and then executing the callback upon success. So I've just kind of gone and grabbed for this one, following the Node.js official documentation. You'll notice if you look at this HTTP request implementation here, it probably looks a lot like one of the older examples on the Node.js documentation. The Node.js documentation is fantastic for examples, and I absolutely love to refer to it and kind of grab things from it where possible, because it saves a lot of time and it really helps you get accustomed with Node very quickly. I've also created methods that work similar to GET for post, put, and delete. Again, just to really speed up how we can obviously write the tests. I'm also using, for the purpose of this project, Jasmine Spec Reporter, as I really love being able to have some visibility on the tests and really see that they're all passing with more than just a few dots in a row. What I'm going to do now is I'm going to run the tests so that we can see how they work and kind of what the tests look like when they run. So we'll go across to terminal. We'll go to projects, sources, Git, GitHub, Iveritech, oops, GitHub, Iveritech, DS My Money is the name of this project. You can see I have a Cordova project in there because I was playing around with Cordova, and also Swift for getting a web application, for getting a mobile version of this application which communicates to the web API. So we'll enter the web API directory, see what's going on in here. We can see we have all the folders and files that we had previously in my side list. And as I've created a bin folder here, which has just some common bash scripts in it that essentially just start the web application. So what I'm going to do is I've created this test.sh, which essentially just defines the environment variables, including, because I'm doing this on a Mac and using MAMP, the location of the MySQL socket, so that it can use socket rather than the port for MySQL. So now that I've described it, we'll go over and make it happen. So bin test. I have also actually set it up in the package.json. When you test, it just runs Jasmine. So as we can see, we've got the nice banner there and lots of errors. And we've got lots of errors because I haven't actually turned on MAMP. So we'll just run back over. We'll get as Node runs the server itself. So now we're on the tests, and now we can see they're all green, except for just a couple there. So once the tests finish running, we'll quickly go over the different tests. So we can see we have two failures there. Now we do get this type error, cannot read property key of undefined. Now that one comes up a little bit, and it is something to do with the auth, which I still have to fix. Happens only really when I run tests, so I assume it probably only happens when the application is being run in volume. And we also have another test here which has failed to update the name of a logbook. So we might, maybe once I've run over the tests, we'll have a look at why that one isn't working and see if we can get that one to work. So as you can see here, we have a total of 60 test specs, and they are all testing routes. So from the top, we have the signup REST API, which tests that signup works by checking that it returns a HTTP 202 accepted on success, that it returns a bad request when the email is taken, and it returns a bad request when the email is restricted. So if we just jump over into the tests, we can see that To check if it returns HTTP 2021 success, we have created an object with an email and a new password, and then we've attempted to post that to the signups route. Coming back, it's expected to be 202 because then we know that the server has responded how we expect it to, and that's essentially all we're looking for in this particular test. In the next one, returns HTTP 400 bad request when the email is taken. We give it, essentially, we create another object with a new email and new password in it. We then attempt to post that once, creating a user, and then we attempt to re-sign up again using that same email immediately. And what do you know? It returns a bad request because the email is taken. We also have a test that returns HTTP 400 bad request when the email is restricted. We created a new object where we try and set the email to just admin and then use a new password. And then when we post that to the endpoint, we see that that is expected to return a 400, which it does. So moving on to the next test, we have the authentication tests, which attempts to log in with an invalid login. It attempts to log in with an incorrect password for a valid username. Attempts to log in with a user that should work and does exist with the correct credentials. And then it just checks that when things are okay, that a token is included in the body. So let's go and have a look at the login specs. Now, what we have here is essentially the same setup as we had in the other one. I realized I didn't quite explain this top section here. So essentially what this is doing is before each test, we are starting the test API, creating a test client, creating a valid login by just generating a unique login and generating a unique password, or a password. And then with the invalid login, creating again a unique login and then creating a password. And then we attempt to sign up the valid credentials, but we don't sign up the invalid credentials because we don't want that user to exist. Otherwise, the request to log in will work. So the first test, we attempt to log in with the invalid login details we created, but didn't sign up for. And as we can see, we use the invalid login and invalid password in the signup, in the auth attempt for a user that doesn't exist, which returns a 400. Then we use the valid login in the next test, the login that we did sign up a user for, and we use the invalid password, expecting that also to return a 400 error code, which it does. Then we attempt to log in with the valid login and valid password that we created up here and created a user for, and that one does return success. Then we have another test to ensure that even though we know it's successful, but we essentially want to find out did it return a token, because that's the most important thing. Because if you attempt to log in and you don't even get a token back, then your login has been worthless. There was no point. So that's the authentication tests. Now we'll move on to the user tests. Very, very basic. Again, it just starts up the test API, creates a test client, creates a new unique login, and generates a password. But then in this case, we're just using the init user function. We're probably not using that in the login spec because I hadn't created that at that time. So in this one, we're using the init user function because it's gives us a token straight away. And in this case, as opposed to the login case, we actually need the token straight away because we're just trying to bring a user into existence, and then go straight from here's a login and password for a new user that doesn't exist. Do all the steps in between and just give me the token and the user ID. With that, we then attempt to fetch the user profile, the user information, using no authentication, so just passing null for the authentication, which over in our API helper, when we pass null, it just doesn't put the authorization header on. So back to the user spec. So we do a test to make sure it returns a 403 forbidden when the authorization header is not provided, which, as we can see over here as the test run, that one was successful. The next test is to make sure that the HTTP returns 200 OK when the authorization header is provided, which again, this one passes. So, and in this one we've passed the authorization, which was the token key. Then in the next one, we're trying to check for does the API return not found when the requested user ID does not belong to the currently authorized user. Now, this is an important one because by making it so that one user can just pull another user's profile or something like that, would obviously, well, in this case would be wrong because that's not a feature. And I don't inform my users that people can just do that, okay? So, and the expectation I would assume with a money tracking application would be that users don't expect that they can just see each other's things. So what we do instead of saying access denied or returning a forbidden is we actually return a 404 not found, so that anybody attempting to try and access our user's information, the server says, oops, sorry, there's actually no page here. So even if you think this is a user ID, well, you might be wrong about that. So what we do in this test is we actually initialize a new user with a different login and a different password. We then attempt to fetch the first user that we created's information using the different login and the different password. And as we can see, that one does return a 404. I might need to fix that test actually. Anyway, in the logbook spec, moving on because that was the last user spec. In the logbook spec, we have, again, starting the test API and creating the test client. Then in the login, creating a unique login and generating a password. Then when we initialize the user again to get a user ID and a token key. Now I love for all of these tests, as you can see this in the before each, so this runs before each test, that it creates a new user, because I like to test it from the start, you know, to make sure that there isn't some type of edge case where you know, just the user for testing is allowed to do everything, and then a new user who signs up actually can't do anything. So for each test, I initialize a new user and then essentially get that user to step through and try the whole thing again. So the first test in here is creating a logbook with valid parameters. As you can see over here, the logbooks endpoints tests are actually a lot more in depth. We have a test here for creating logbooks, which checks that it returns forbidden when there's no authorization header. It returns OK when the authorization header is provided. It returns that for a successful request, that the response body is an object and has the correct value for the one property that the user could specify. And that subsequent requests to fetching a list of logbooks include the logbook we've just created. Then we have some tests for fetching lists of logbooks, where it returns forbidden when there's no authorization header provided, and it returns OK when an authorization header is provided with an array. Returns a 200 OK with an array. Now, we also have tests for updating a logbook's properties, namely changing the value for the name property. As we can see here, these tests didn't quite work properly, but we're going to delve into those a little bit deeper. So, and then changing the value for the currency property. We're making sure that that returns OK and that it updates the value correctly. Now, in the user interface, they can't actually choose the currency. The currency is just defaulted for them. But the currency has some rules around where the decimal place goes and what currency symbol, obviously, it uses. Now, the main reason I've actually implemented something like that is because I don't actually use floating point numbers in this. I actually store the currency against the logbook. And then the logbook, when you're entering, say, $1,000, it actually adds that in as 1,000 with an extra 2 zeros at the end, knowing that where the decimal place is meant to go. There's some issues with Node and rounding. So just to kind of avoid that whole kettle of fish, I have just decided to essentially skip past that and just use, again, a common trick that I've seen anywhere and everywhere, which is just defining where the decimal place goes as part of the currency. So we also have a test in here to make sure that we can delete a logbook, and that works, and that subsequent requests to fetching a list of logbooks doesn't include the deleted logbook. So let's go and have a look at this one. So as we can see in here, before each test, I'm initializing this array with the name and the currency. Then on the first test, I attempt to post it without any authorization. Then on the second test, I attempt to post it with authorization. Then I attempt to check for a successful request in the response body. Does it return an object? And does the object have the same name that we submitted? Then there's a test in here for the subsequent requests. So as you can see up here, So what it does is it attempts to create a logbook, and then once that is complete, it goes around to fetch a list of logbooks and then ensures that the ID that was returned for the new logbook we just created exists in the array of all logbooks with the same name. So the next set of tests in this one is fetching a list of logbooks. Now, if we've kept this one a little bit simple, we've just kind of put basic kind of testing in here where we just say checking for do a get for all logbooks, make sure it's 403, forbidden when there's no authorization, and then when there's authorization, we're essentially just checking that it returns 200 and that it is an array. Now this test is a little bit simple because we could be passing a different user's authorization or something like that. But this isn't really testing whether or not a particular user can do something. It's just kind of testing that given that all things were okay and that we had a user that we knew existed, that if we could fetch a list of logbooks. So all users have the get logbooks all. So provided that you had a valid account. So now we're checking fetch all logbooks. Sorry, we just did that one. So now we're describing logbooks when we're fetching a single logbook or updating a logbook. So before each test, we're creating a logbook in the database, or we're creating a logbook through the logbooks endpoint. Then we're going to update logbook properties. So in the first one we're going to try and do is change the name property by essentially saying here in this new logbook name. Now the way I've implemented puts on this is a little bit different to the HTTP spec. Again, this doesn't follow the spec fully because then there would be all kinds of stuff in here. So essentially, what we're doing is we give, when we're just updating a single value, I've actually created a system where you go the resource /resource ID /property name, and then what we do is we do a put to that with an object containing one property, which is new value, which has what the new value is supposed to be. And then you can see here we're doing that put with the authorization to /logbook ID name with the object which contains the new value. So we can see we got 200 back from here. So that was the first thing we're checking to make sure that the server says, oops, everything's okay. That worked. Then we have another test in here to make sure that's great. The web server said 200 success, but we want to make sure that when we do a subsequent request for that logbook, that the name has actually changed. So we do the same test. We put a new logbook, and then we go and attempt to fetch that logbook and make sure that the name has changed as we expected. Again, we do the same thing with the currency property. Just swapping out, obviously, the values and the property name. Then for deleting logbooks, again, testing that it returns forbidden when authorization header is not provided, and that if you are the resource owner, then it returns OK when the authorization header is provided, and that subsequent requests to /logbooks_all doesn't include the newly deleted logbook. So when you go test client delete with the authorization and the logbook, and then once that's done, we do a get to logbooks_all and expect the array to not contain the object with the ID and name that we just had, that we just deleted. So that's all the logbook tests. So now what we have is some transaction tests. Now the transaction tests, again, essentially do the same thing. The logbook tests are the same as the transaction tests. Sorry, yeah, the transaction tests are the same as logbook tests, essentially just for transaction properties and transaction properties and etc. So transactions, as we can see in here, before each test up here, again, we're just creating a test API. Starting the API, creating a test client, again, creating a unique login, generating password, initializing the user. Then transactions, we have in here, we define the logbook data and the logbook because we're going to be reusing the same logbook, and then the transaction data here. So before each, we initialize when the transaction occurred because we actually have a number of properties here. We have, for a transaction, we have the summary, the amount, and the date it occurred. Now, in the backend, we actually, like in the way this is stored in the database, we actually have a difference between when a transaction occurred and when it was created. So when it was created was literally when it was entered, which obviously the end user doesn't have control over. However, they can control the occurred date, which is essentially where the application will put that transaction in the list. So then we have the logbook data, and basically in the before each, we just essentially create the logbook, and then set in the transaction data the logbook ID. So when we create a transaction with valid parameters, we have top level transactions. You can see I've just done a find and replace on some of the stuff from the first app of these three that I created, which was a nested list app. So for top level transactions, it should just be saying transactions. But again, I actually built this whole thing in about a day. Now that may seem kind of crazy and impressive, but I had just built 2 others in the previous days, and I had essentially just copy pasted all of that from a previous project that I actually spent several months working on. So that explains why some of the stuff may seem a little copy pasta, and you can kind of backtrack that through all the way back to essentially the first version of this, which I actually called Data Studio, which was actually an API design tool. Now back to the point. So first thing we're testing for is that it returns forbidden when the authorization header is not provided. So again, we don't provide a header, and then we attempt to post a transaction with this transaction data, which returns 403. Then we attempt to check when the authorization header is provided that the transaction is successful. Then we check, does it return an object in the response body for a successful request? To make sure that, again, the server's not just saying, hey, everything's okay, but everything's not because you didn't get the object back you expected. So it's just kind of making sure that the server isn't saying everything's okay, but everything's not okay, which sometimes happens. So then we're checking to make sure that it returns an ID property in the response body for a successful request. Then we check that the transaction can be fetched using that ID property. Then we check that the value we specified for the summary is the summary for that transaction with that ID. Then we check that the correct value for the amount property has gone through. Then we check that the correct value for the occurred property has gone through. And then this is where it gets interesting is as well as just checking to make sure it adds the transaction to the logbook's transactions property. So when we fetch the logbook, there's a transactions array which comes back. And we're checking to make sure that this new transaction we put in just now actually comes back when we fetch that logbook. And then we're also checking to make sure, because the logbook has a computed balance property, we're checking to make sure that the balance now has changed for that logbook to what it now should be, to the value of the new transaction, essentially. So transactions in this can either be positive or negative. So you can be, a transaction could be credit or debit. And so obviously it has to make sure that the application updates the logbook's tally, the logbook's total correctly. So then it adds the transaction to the list of logbooks transactions. So we check that looks good. Then down here we have a little bit more about the transaction. So we have some tests for the transaction route itself. So in this one we'll be testing, does it return the right things? When we change it, does it, when we change something like the amount, does it update the total on the logbook properly? Now keeping the logbook as a value stored, keeping the total as a value, as a property of the logbook, actually is a massive performance boost, because that means that we don't have to write these queries that kind of try to go for X many transactions, get them all in and then calculate them all out. Because what if somebody one day has 10,000 transactions in there and then they log in and my whole server essentially just crashes because somebody has a whole list of logbooks which each have 1,000 transactions, and then suddenly my server's crashed because it's gone and tried to calculate what all of these transactions add up to, and is the transaction deleted? And then you've got to wait for MySQL to filter through all this data, and then you've got to wait for Node to kind of put it all together and then calculate it all, and then there could be all sorts of kind of hidden bits in there. So essentially, you can see this transactions tests has quite a lot in it, and that is because, as we'll go through this, we'll actually see that it does a lot of stuff to make sure that, hey, when we update the value of a transaction, say to minus, say we suddenly change a credit to a debit, or we make it so it's a credit of $5 instead of a credit of $7.50, to make sure that the logbook updated properly and the transaction updated properly, and that everything's all kind of above board. So we start that off by, again, before each kind of creating this transaction. And then we put, and then essentially entering into the database, and creating it through using the post transactions route. First thing we're going to do is super simple. We're going to change the occurred property to make sure that updates. Okay, so I've got a cool little sugar thing on this occurred property, so that if you're just kind of creating it, you can just say if you're updating the occurred property, you can actually just say now, and then whatever the time is now, it actually sets that as the occurred. Which is cool, because that means on the UI I don't have to try and handle weird exceptions or weird cases about when was this created, or sorry, when did this occur, so that way they don't enter it in their time zone and then something gets lost in between the UI and the server, say because of a browser bug or something like that. So as you can see in here, we check to make sure it's okay when the server says it's okay, and that also that it did actually update it to what we told it to update it to. So we can either set the occurred property to now, we can set it to a timestamp, or we can set it to null. Well, I mean, in the test we can't actually set it to null. The test to see if we can set it to null actually just tests that it actually returns an error saying, well, you can't do that. You can't have a transaction in here and just not say when it occurred. So you can see here, got the put occurred, then put transaction occurred, and then get authorization, and then we check to make sure the occurred is the exact same as the timestamp, Then we test in here what happens when we set the new value to null, and what do you know, it returns a 400. Then we have some tests for changing the value for the summary property, which again returns HTTP 200 OK. We just essentially post to the transaction/transaction ID/summary property, and then we check to make sure it returns OK, and then we check to make sure the value has been updated correctly. Now, the next test is changing the value for the amount property. Now, this one is where we get quite a bit because we actually have a few cases in here. So one of the things we're testing for, I'll go back over here, is that when we are updating, changing the amount property, we're making sure that if we change it to a higher positive number, that updates values logbook correctly, to a lower positive number that updates it correctly. And then for positive numbers, so credits, we're making sure that that updating the transaction amount to a higher positive number actually updates the balance correctly. Updating it to a lower positive number updates the transaction correctly, updates the logbook's balance correctly. Updating it to an amount, updating the transaction amount to a negative number from a positive number, so to a debit from a credit, that also updates the balance correctly. And that if we're updating the logbook transaction amount to 0, that also updates the balance correctly. These are all weird cases that kind of, as I was actually initially writing the tests for these and I was kind of mapping it out on a piece of paper, I actually realized that there were a lot of kind of cases that I wanted to check and be sure of in this. So then we have negative numbers. We have tests for negative numbers, making sure that if we update the transaction amount to a higher negative number, that it updates the logbook balance correctly. When we update the transaction amount to a lower negative number, that it updates the balance correctly. That when we update the transaction amount to a positive number from a negative number, that it updates it correctly. And again, that essentially zeroing out a debit again works correctly and doesn't have any weird kind of edge cases like maybe if you're trying to set it to 0, it doesn't update the balance properly, or maybe when you're doing trying to turn a credit into a debit, that it doesn't like accidentally just minus say the new debit amount from the credit amount. So there's like all whole kinds of C's of like things that could go wrong there. Or like places where there could be a weird kind of edge case. So deleting transactions, that one's pretty simple. We'll cut back over to the tests for this so we can see how these will work. So what we do is, when we're testing if it works for a higher positive number, we create this we've created this transaction. So then we try and change the value of it to a higher number. And we expect that to return okay. So the server says, yep, got it, worked. Then we try it again and we say, but we want to see and make sure that the amount was actually updated on the transaction, which again it was. Then we're checking, okay, great. So now that we've made this change, we want to check that the logbook's balance as well has also changed. So we do that by again attempting to put the new value and then getting the logbook and then making sure that the balance is now essentially the new value for the transaction, because the logbook only has one transaction in it. Because it was created, this whole user was created before this updates the logbook's balance properly correctly. It created a new user, it created a new logbook, it created a new transaction, and then it's trying to update that value. And then we're checking that in this brand new logbook and this brand new user, when we change that amount, did that amount change as expected? And what do you know? It did. And we check to a lower number. Again, these tests, I love these tests because in the test, it looks so simple and you're like, why do you even need to test for that? It's just so simple. And you're like, the tests look so simple, but at the end of the day, the time this saves you, and actually with specifically working this out, there was actually a lot of to and fro where I actually had to keep going back to the piece of paper and being like, whoa, wait a minute, I've managed to contort this all in my head. And then it was only because of the tests and because the tests were so simple and that I knew that if you're changing this to this, it has to end up being that. It really, really saved my life to have these tests. So again, we make sure that it updates the value correctly. So here we go. So we've got this one where we've got positive numbers. We're making sure that updating the transaction amount to a high positive number updates the logbook's balance correctly. So again, we have this new transaction, we set the new value, and then we go ahead and put that new value, and then we get the logbook and check that the balance has been updated, where we have some safety and some sanity. So updating the transaction amount, positive numbers, we're essentially making sure that the logbook's balance property is updated correctly. When updating the transaction amount to a lower positive number, that the logbook's balance property is updated correctly. Again, we just kind of do the same thing, but trying to do a positive to a negative to a lower negative, a negative to a higher negative, etc. And then just making sure that all flows and that all works. And then yes, that brings us up to the last set in the tests, which is deleting transactions. Now, for deleting transactions, we have transaction ID, transaction data. Before each, we're creating the transaction. Then, as the resource owner, some of these tests are actually a little bit around the wrong way because, as you can see here, actually, I guess, you're right, because it says, as the resource owner, does it return a 403 forbidden when the authorization header is not provided? May seem like a bit of a weird test because it's kind of being like, I do technically own the resource, I do technically own the transaction, and it does belong to me. However, I'm not going to provide authorization. So I guess I'm just kind of putting weird hats on the test entities, maybe. Getting them to just, be smarty pantsers, perhaps. So then on a successful request, we can check that, does the transaction update? Deleting it, does it return 200 okay? Technically the HTTP spec says that when you put it, do a delete request to something, that it should return an empty body and just say okay. So some of the things are as you might expect, and that it removes the transaction from the logbook's transaction properties. So we have delete transaction and then get. So we attempt to delete the transaction and then we attempt to get the logbook and then check that the transaction isn't in the list of transactions on the logbook. We remove the transaction from the logbook's list of transactions. So we make sure that when we do a delete, and then do a get for logbook /logbook ID /transactions, that it doesn't come back in that array either. Then we check when we update the logbook's balance property, the deleting a transaction updates the logbook's balance property. So when we delete this transaction, does it update the balance correctly? Okay, so that is the tests. I know I said I was going to try and help fix this other one. However, I believe it may have been just that weird edge case where I believe it's an MySQL issue. So we'll run the test again and see if that one passes. And again, to a lower positive number, we're still getting that cannot read property key of undefined. I think that might be on a different one now than it was previously. Logbook ID. Previously it was when we were updating logbook properties and changed the value for name, and this time it's changed the value for the amount property on a transaction. So this error is one I'm still working on. This one only seems to come up when I'm running tests. I imagine it probably comes up in production, possibly, if anybody else but me used it. I actually use this quite successfully on a day-to-day basis. My UI, I actually have it just retry the operation if there was any error. So the UI kind of saves people, on that thing. So if the backend goes, oops, there's a problem, then the UI just goes, just try again. So we can see here if we run the test again, they will likely all pass. It also depends on how much my MacBook is doing. So it could be, it's just one of those weird edge case bugs that next time I get 4 weeks to just kind of like mess around with things, I'll probably figure it out. Or a chance to talk to somebody who is actually skilled with Node, I might also get a chance to figure it out. So you can see this time it's passed and we've just literally just run them again. If I were to run them again now, quite possibly we would have that key issue in another place. It's quite possibly that I'm passing an object through somewhere, and that the object is being changed somewhere. Perhaps it's got something to do with the garbage collection or the reuse. Is where I'm thinking it is, because it literally doesn't make any sense, and I have actually looked into it quite a bit, and so I'm imagining that because JavaScript, obviously, you have by default you're just assigning things rather than creating a new instance of things. You say in like PHP, when whenever you assign something to a new variable, you're duplicating it. Whereas in JavaScript you're not, and that actually does cause quite a lot of weirdness if you don't know what to look for and if you don't know what it's doing. So yeah. But essentially, this was my tests. I hope you liked them. I hope it wasn't too confusing. And yeah, I mean, if you like this video, then I guess subscribe, and hopefully there will be more. Yeah. Thanks. Bye.